Hi, welcome back. So we are in section 4, exceptions and error, to discuss the second outline, handling exceptions. So in case to look at the subject of handling exceptions, first we'll be looking at this try and except clauses. We have seen in the previous session about these two functions and how the exceptions would occur if, of course, you would have to call either directly the no return kind of function, or you can call the second function that is called the function that raises the exceptions. However, in Python, we use a clause called try. So in this case, if I would have to use the try, inside the try, I could call the no return. And if case of any exceptions would happens, then I would use the word except. So it's a try and except. These are the two clauses we use. Here I would maybe want to print a sentence, and then I would maybe make a general print. Let's try to run this one, of course, after I call the call function anyway. Now watch carefully what happened after I call, of course, to go and try. He's inside the no return. Of course, this line will be printed. This is the first line. Now, when he encountered an exceptions, unlike before, he did not stop the application. In fact, he break down here and get back to this particular line called except, because an exception was called. And he printed this line. I caught an exception. And after that, supposedly the program should be terminated or stopped, but in this case it didn't. He just print the last line here, which we call this is an executed after the exception. So this is the use of this clause called try and except, and can be really helpful in so many different situations. Let's try actually to create this example from a different perspective. Let me here write, for example, math function, something like that. And let's assume this particular function, it take a number. And what I want to do, I want to try to return 100 divided by the number you pass. Simple. And here I'm going to use the except, of course. Instead of particularly go with a very generic form, I'm going to except for a specific type of error. Let's call it the zero division by error, because I don't want the user to divide by zero, right? I want to return, let's make just a sentence. Now, if I would have to go to math function, let's say 50 or something like that. Let's try to run that. As expected, I get 2. But how about if I put 0 here? You should, of course, anticipate it's going to be 0 is a wrong thing. Okay. But what if I would have to put a different value? So beyond the line of this except, because I was very specific with the type of error I'm talking about. Let's run this one. Now here I am getting back to the same old picture. If you remember, it's a type error, unsupported operation of integer and string, something like that. So in this case, what we could do, we could make much more than one type of error can be handled in this case. So I would have to come here, parentheses, just like so, and add one more type of error. And let's call this type maybe type error, something like that. Now you should be enjoying the same exact result as before. Why? Because I had a new type of error. So I could have as many type of error actually as if I want to. Let me show you something more interesting. If I would have come here and check a condition inside the try. If say the number, it says equal to a specific number like 13. I want to raise an error here. Now I am raising an error, right? And let's call it a value error. And I could give it 13 is not accepted, something like that. And you know what I'm going to do here? I'm going to just loop inside a number of those errors. Let's put 0, let's put string high, and let's put maybe a legitimate number, and 13, I mean, to meet the condition exactly. Just a print sentence here. We can just put the value number, and then after that, let's make one more print function. Let's bring now the call. It's a math fun, and I'm passing the value. Before that, I just end with nothing. So make sure the result will be next to each other. Let's run this. Okay. So test value of 0. 0 is wrong. Why? Because I'm using this particular message. Test of high, the string, 0 is wrong. So he's using the same text, and this is something is annoying. We can go over it now, I'll show you. It's the legitimate value, the 50, and 13, then he raised this error. And if you change, by the way, the location of 13, if I would have to come to 13 here, you should anticipate that 50 will not be executed. So if I run this one more time, as expected, 50 will not be executed because this raised error had occurred. But to solve this particular problem of, having this text to change depends on the error, and I could make one more exception, and if it is a value error, a string is not accepted. Okay, if I run one more time, I just noticed this is not value, so put it a type error, otherwise we'll be throwing an exemption. So as expected, everything, you see, string is wrong because he defined the exception to be of a type error instead of the other one. Now let me show you an example that put things more clear. Let's just choose here a module called random, and let's call some exceptions here. The exceptions that we have learned so far, let's put them in a list. And we have none. I mean, there is no error at all. Let's go with the try. And let's make a choice. And let's call random.choice from this some exceptions error. So here choice will choose every time a type of error. Let's print now, put the actual choice that we were talking about. Now I want to say if choice has been truly chosen, I will raise now that particular choice of the error. Let's make now a few exceptions. If it's a value error, let's make a print. If it is a type error, of course I'm going to say it's a type error. If it is index error, I'm going to say it is an index error. And here is where I want to introduce you to something new called except. Let's make one more except, by the way. But this time I will say exceptions. See, this is a generic exceptions because all these classes, value error, type error, index error, are actually inheriting from exception. But this time I will be very specific as a. Watch carefully, exceptions as a. And this time I'm going to print here. I will use the e dot. I'm going to take the class, which class he inherited from, and maybe I could also take the name of it. Next important things I want to share with you is the else concept. So we have a try and any of these except, and then else. Else means if none of these errors occurred or erased, I will print here a sentence, else now will be executed if none of these exceptions occur. And finally is the last word to introduce here, and let's print. If we execute this particular part of code, of course, every time if we run a few times, it will be choice randomly from these. Let's try our luck and see what will happen. So in the first round, he chose to go with this type of error and quote an index error. He printed that. Let's try one more time. Raise a none error. Perfect. So he went to this choice, by random. And then when he is inside none, watch carefully what happened. He did not print any of these type error, but actually he went to the else here. This code is called with no error. And finally, the sentence always printed. So this was just an illustration to show you three important terminology of using the as and the else, etc. Now, why is this finally sentence is really cool and good? Because it can be really handy. Always will be executed, no matter if there is an error or there isn't an error. You saw it. So sometimes you need to clean up and open a database connection, maybe close a file, send a closing handshake over a network, etc. So if the error occurred, you will not be worried at all. So we have seen all these, the try and accept, and the else, and the finally. Last things I want to share with you quickly, it's something related to the hierarchy, exceptions of hierarchy. So the takeaway here is to see that this particular class, system exit, and this class, keyboard interrupt, and the exception class, the big one that have all other kind of class, the inheritance tree, this basic class looks like this. It's very important when we make the call, we need to make sure that we don't actually encounter double calling one way or another. So that was all about the discussion of handling exceptions with this clauses of try and accept. Next, we will be talking about defining our own exceptions and customizing that. I will see you then.